Molly?
My final's on Thursday for math.
Okay. So, what are we working on today? Can you verbalize it?
Could we go to the same place as the other time, but go to Unit 2?
Yeah. I believe I have that saved. Mr. Sweet Math?
Yes.
It's a strange name. I have a sister-in-law that's nickname is Sweets. And which assignment?
Like questions, I guess, where it's like if you have like the adult tickets are this much, and then the children tickets are like so like real world meaning, I think.
Which one is that?
Um,
Real world meaning. Okay.
25.
Most important thing about doing a word problem, what's the first step of a word problem? If you get the first step right, it will not be hard. Got to get the first step right.
They're like organizing it right and stuff.
No, it's defining your variables. Well, maybe I spoke too soon. Let's have a look at these problems first of all. So you decide to run a marathon. However, you can only run for part of the distance and walk the rest. You run at a rate of 8 miles per hour and walk at 4 miles per hour. Let X represent the number of hours you run, and Y represents the number of hours you walk. So that's our first step. They've told us what to let the variables be. So let's do that. And when you do this, when you're first getting used to this, write it out. Number of hours you run, and Y is the number of hours you walk. And the reason I say that is because when you have your movie theater problems, where you're buying popcorn and Coke, the X could be the number of Cokes you buy, or it could be the price of the Coke. So it's not always clear. So that's why I say it's really important to spell these out. X is the number of hours that you run. Okay.
Okay.
So, can you give me an equation that will state everything? In other words, let's do A.
So,
first of all, something has to be equal to 26.2, right?
yeah.
That's the length of the marathon.
Would it be like 8x plus y?
Well, let's examine 8x. 8x is the number of, or X is the number of hours that you run. And you run at a rate of 8 miles per hour. So yeah, if you run for 2 hours, you're going to cover 16 miles, right?
Uh-huh.
Okay. Now let's add to that the amount that you walk.
So then 4y?
Yeah. And each one of these stands on their own. If you could run the whole race at 8 miles per hour, then it would only take you like 3.5 hours to run it. There wouldn't be a Y. But
Right.
if you're walking part of it, then the total distance covered is the amount that you run plus the amount that you walk. And that gives you 26.2. Now, let's go to the second question. How do you get the x-intercepts?
Wouldn't you have to do minus for y to get it on the other side?
No, there's a very key thing that you have to recognize in math, is that when you're looking at x-intercepts, that's that point right there. What's the value of y?
The what?
What is the value of y?
4?
No, look, this is an xy coordinate plane. That's the x-axis, that's the y-axis. You're familiar with coordinates, right? If I told you to plot 3, 4, you'd know where to put it on this graph?
Yeah.
Okay. So when I'm showing you a graph, which is a straight line, and I'm saying, what is this point right there? Well, what is the y-coordinate there?
0.
Yes, that's what I'm trying to get at. So we're going to make y 0. And when we do that, it takes out that 4y. So we get 8x equals 26.2. Do you have your calculator in front of you?
I do not.
Can you get it?
I think it's in my backpack or upstairs.
You should always have a calculator in front of you when we're doing sessions.
Yeah, I got it.
I'm always wanting you to get these answers. I don't want to do it on my calculator. That doesn't help you.
Then 3.275.
Okay, so 3.275 is the x-intercept. That's what that point is right there. 3.275 comma 0, right? Because the y-coordinate is 0. Okay, what does it represent in this situation?
The hours run.
Well, remember that y is the hours that you walk. X is the hours that you run. We're basically saying y is going to be 0. So you're not going to walk any hours. So that means if you ran the entire race, you'd finish it in 3 hours, 3.275 hours. Okay. Now, what's the y-intercept?
4.
Well, no. What is true? This, I'm not sure why so many students have a hard time understanding this, but it's really, really key. When you're talking the y-intercept, what do you know about x?
It's 0.
Exactly. So if you plug in 0 for x into our equation, what do you get?
So then it would be 4 divided by, 26.2 divided by 4.
Exactly. What is that?
$6.55.
What does that mean?
So if you walked it, you would walk it in 6 hours and 55 minutes.
Well, almost. It was really a good answer, but 6.55 is 6.55 hours. It's not 6 hours, 55 minutes. Understand the difference?
Yeah.
Okay. Because 6.5 hours would be 6.5 hours, which is 30 minutes. So 0.55 hours is going to be a little bit more than 30 minutes. Okay? But the fact is, we don't really need to put it in hours and minutes. In other words, that is a good answer. That's 6.55 hours, and that's a good answer. So we know that if you ran the whole way, it would take you 3.275 hours. If you walked the whole way, it would take you 6.55 hours.
Mm-hmm.
So now let's talk about the domain and the range. And in this case, we're looking at that equation right there. That is the equation that represents this situation.
Right.
Domain refers to which variable?
The x.
Okay, what are possible values here for x?
Wouldn't it be 3.275 to infinity?
Well, not in this case. In this case, in other words, think about it realistically. Can x be negative?
No.
Okay, can
Yes.
x be 0?
So 0 to infinity?
Hold on, can x be 0? In other words, can the number of hours that you run be 0?
No.
Why not? Can't you walk the whole thing? We just showed what happens if you walk the whole thing. It takes 6.55 hours.
So yes.
Exactly. X can be 0, and that makes it a bracket, not a parentheses. And what's the maximum that x can be?
Infinity?
No, because you're only running a marathon. Remember, x is the number of hours you run. So the most x could ever be is that, because you'll finish the race. If x is 3.275, you'll finish the race. So x will never be able to be 4 or 5 or 6.
Okay.
You see why?
Yeah.
Yeah, because if x were 4, it wouldn't work. That you'd run 32 miles. You wouldn't run 26.2 miles.
Mm-hmm.
As long as you're running, x is the number of hours that you ran at 8 miles an hour, then x is limited between 0 and 3.275, and that also deserves a bracket. Now, do you know the difference between brackets and parentheses?
Yeah, if it's a bracket, it stops there, but if it's a parentheses, it goes on.
Well, kinda. If I had to put a parentheses there next to the 0, then it would not have been able to be 0. It could have been 0.1 or 0.01 or 0.001, but it would never have been able to be 0. Well, in this case, it can be 0. You can choose to not run a single minute, which would mean x would be 0.
Mm-hmm.
And it can be exactly 3.275, because if you ran for 3.275 hours, you would run 26.2 miles, you'd be done. So there's no way x can be 3.3, but it can be exactly 3.275. There are some times and some types of equations where it can't be that number. It's got to be greater than that number. So you might find a domain like this, but it would be surrounded by parentheses, meaning it could not be 0. And if I said to you, if I look at that, the domain of 1 over x, x cannot be 0. So if I were to say what the domain, I'd have to put parentheses. Actually, I would go negative. negative infinity to 0 combined with 0 to positive infinity. That right there is interval notation. Are you familiar with that word?
No.
Okay, well, when we're writing things like this, that's called interval notation. And that's where you have to be very careful as to whether you use parentheses or brackets. So I'm getting a little ahead. I don't want to do that. So last thing we want to talk about is the range.
So then would it be bracket 0 to 6.5 bracket?
Yeah. Yeah, I can only think that that's what they mean here. This is not a particularly good problem to illustrate domain and range. But yeah, effectively the domain is whatever values x can take on, and range is whatever values y can take on. All right, let me scroll down a little bit. And we'll have a look at problem number 2. I don't know how you feel about word problems, but I've never met a student yet that didn't hate them. Okay?
Yeah, I don't like them that much.
Well, yeah, and that's because, and the reason that's true is because students don't know how to start the word problem. If you figure out how to start it, it will not be a problem. It's pretty easy to come up with the equation if you figure out what the variables mean.
Mm-hmm.
Well, where do you go to figure out your variables? You go to the last sentence of the word problem. Seriously. Now, they're making it easy for you here because they're telling you what your variables should be. Usually, that last sentence would say how many 2-point baskets and how many 1-point free throws were made. You can still figure out how to set up your variables. In other words, x is the number of 2-point baskets, and y is the number of 1-point baskets. So even if this were a typical problem where the final sentence said how many 2-point baskets, how many 1-point baskets, that's where you define your variables. And 95% of the time, you can look at a word problem and go to your last sentence first. That's what I do all the time. I go to the last sentence because the last sentence is where they ask the questions. How many hot dogs were served and how many Cokes were served? So you let X be hot dogs, Y be Cokes. Whatever they're asking you for, that's what you want to let your variables be.
Okay.
All right. So, in a game before 1979, a team scored 128 points. What's the equation that's going to represent this situation?
Wouldn't 128 be after the equals?
Let's start from left to right. Yes, I'll give you that. I don't want to take that away from you, but I want you to think from left to right.
So then 2x plus 1y.
Perfect. So that's the answer to A. What's the x-intercept?
So it would be 128 divided by 2, right?
Uh-huh.
So 64.
What does that represent?
The 2-point baskets.
Yeah, what does it mean? What happened in that game?
They got 64 2-point baskets.
How many 1-point baskets did they get?
Wouldn't it be 128?
How many 1-point shots did they get? What's y? Y is the number of 1-point shots. What did you let y equal to in this problem?
1.
0. When you are talking about the x-intercepts, y is 0, right? In other words, always think in terms of graphs. It doesn't matter if it's a curved line or not. If I'm trying to figure out what that point is on the x-axis, I set y equal to 0 because that's, I don't know what the x-coordinate is, but I know for sure the y-coordinate is 0, right?
Yeah.
That's what you're trying to do here. So you've set y equal to 0. Well, what's y? The y is the number of 1-point baskets. So x equals 64 means what happened in this game?
There are 64 2-point baskets.
There you go. That's what it means. There were exactly 64 2-point baskets and 0 1-point baskets. Okay. What's the y-intercept?
0 y.
What do you do to figure out the y-intercept?
Y divided by 128.
No, hold on. Let's go back to our master equation. That's what governs everything. If I'm trying to figure out the y-intercept, what's x equal to?
2.
Okay, look at my graph over here. There's your y-intercept right there. What's x going to be equal to at that point?
0.
That's what I'm trying to teach you. That when you're trying to find x-intercepts, y is equal to 0. When you're trying to find y-intercepts, x is equal to 0. So what's y-intercept here?
0.
X is equal to 0, not y. It's always the opposite. In other words, when you're trying to find the x-intercept, you set y equal to 0. When you're trying to find the y-intercept, you set x equal to 0. Well, what happens to our equation when I set x equal to 0? What is y equal to?
0 y.
Okay, I want you to start from this equation. And I want you to set x equal to 0 and tell me what y is equal to.
1.
Well, 2 times 0 is what?
0.
So I've got y equals 128.
Yeah.
What does that mean? If the y-intercept's 128, what does it mean happened in this basketball game?
There are 128 1-point baskets.
Yeah, that's what it means. So what they're trying to tell you here is those intercepts, and this graph that I drew, let's redraw it because it's good to understand the graphic display on this thing. So we got a y-intercept of 128. We got an x-intercept of 64. Well, this happens to be a linear relationship. So there's the graph of how many points we're going to score. And this y-intercept, well, not the number of points we're going to score, but that's the y-axis, that's the x-axis. Okay? So if I'm on that point of the line, that looks like maybe I scored 32 2-point baskets and 64 1-point baskets. You get how this works?
Yeah.
Okay. So we've done A, B, and C. Let's look at D. What is the domain in this situation? What are the possible values for x?
Would it be bracket 064 bracket?
Good.
And
It's bracket 0, comma 64 bracket. Okay. And there's many ways to represent domain. This is just one of them. I could also say x has to be greater than or equal to 0, and it has to be less than or equal to 64. There's no way you could score 65 two-point shots. The score would not have been 128. It would have been 130. So I can be at 64, but it can't be any bigger. So this is probably the way they want you to give your answer. Okay? Just because you told me they haven't taught you interval notation yet, this is interval notation. And you'll notice that brackets go with the greater than or equal sign. And if these were parentheses, then that would just be a greater than sign. It wouldn't be a greater than or equal.
okay.
Okay, so that's how you go from this kind of notation to interval notation. You'll get interval notation, but maybe not for a year.
I think, well, we've done like the bracket sort of stuff for domain and
Well,
range.
that's interval notation. So maybe they've given you a little bit of it. Okay, the thing to always remember is this master equation. Okay, so we've figured out the domain. What's the range?
Would the range be bracket 0, comma 128 bracket?
Yeah, it would be. And again, I really hate them asking range on this problem because we know the range, right?
Yeah.
Not really 0 to 128. I'm not sure that's the right answer. The right answer is 128. In other words, they gave us what the range was. Well, hold on. Let me take that back. No, I take that back completely. We're not looking at total points scored here. We're looking at a relationship between the number of one-point baskets and the number of two-point baskets. Nowhere on here really is the number of points scored. So range is definitely correct, 0 to 128. All right. Let me scroll down here and let's have a look at number 3. So you're investing money. That's what it means when you're starting a Roth IRA account. Okay? You got $300 from your graduation and you're going to invest it. And you're going to add $50 every month. Okay? Write an equation in slope-intercept form. What's slope-intercept form?
Y equals mx plus b.
Okay. To determine the amount of money, Y, in dollars, when you know the number of months. What's our variable?
X.
What's it equal to?
Months.
It's the number of months. When you're first doing these, spell it out so it is crystal clear. It's the number of months since you started. Okay? And this is extremely important. The more detailed you are, the better you will understand the problem. Okay? You don't just want to say x equals months, because that if you say X equal the number of months since you started, you can picture it in your brain. You can picture graduating, taking this $300 of graduation money and investing it. In July of, when are you going to graduate? 2021?
High school?
Yeah.
22.
2022. So that's when you're going to invest this $300 you got from graduation. And then every month after that, you're going to add $50. So we want Y. Remember what Y is. Total money invested. Okay? That's what Y is. So what's Y going to be in the context of this problem?
Would it be 50x?
Well, now I want you to think about if X is 0. How much do you have invested?
300?
Yeah, well, does that equation give you that?
No.
Okay, so what do we need to add? Remember, it's Y equal mx plus b.
Oh, so plus 300?
Now, if X is 0, how much is Y?
50x plus 300?
X is 0, how much is Y?
300?
If X is 1, how much is Y?
350?
If X is 2, how much is Y?
400?
Does that match our problem?
Yeah.
You're depositing 300 immediately, and you're going to add 50 every month. So after 1 month, you'd have 350. After 2 months, you'd have 400. So this equation matches everything perfectly, as long as we know what X and Y are. Okay. So it also satisfies, we're in slope-intercept form, to determine the amount of money in dollars given, you know, the number of months. So this is perfect. Okay, hold on a second. I've covered up some of what I need to read here. So write a function m that determines the amount of money in the IRA in terms of the number of months t. So let's erase everything for starters, because this is a whole different problem. We want to keep our master equation. Remember what that means. X is the number of months you invested. Y is total money that you invested.
Yeah.
Y, incidentally, is not what your account is worth. Y is merely the total amount that you put in. Okay? And there's a difference, because you're investing money because it's going to earn interest. So Y is never going to be the amount of money that your account is worth. It's only going to be the amount of money that you invest. In other words, we've written this. Now write a function m that determines the amount of money in the IRA in terms of the number of months since the IRA was started. The function will not include the compound interest you are earning. So m, that determines the amount of money in the IRA in terms of the number of months since you started it. So what is m? Don't confuse m with slope. It's not. M is just a total different variable.
Is it number of months in time?
Okay, so what's the equation going to be?
M equals
Instead of x, they're letting t be the number of months.
So then would it be 50t plus 300?
You got it. In other words, this is the same as this. The total amount that you put in.
Okay.
Does not include any interest that you earn. So there's no difference between y and m. Okay? It's just in this equation, we let y be that amount, and we let x be the total number of months. And in this equation, they call it function format. What they really did was just change the variables. M is equal to y, and instead of x, we use t. And that's fairly common in math. When your variable is a unit of time, then you tend to use t instead of x. So even in this one, they told us to use x, but in this one, they told us to use t. So you can use either one, and either one means the same thing. In other words, this is the same equation as that. It's just that m equals y and t equals x.
Yeah.
Okay. So identify and interpret the slope. What's the slope of either equation?
Is it 50 over 1?
Yeah. So what does that mean?
50 over 1.
And what's that mean in the context? It says interpret the slope. You've identified it. 50. What's it mean?
And every month you invest 50?
Exactly. Every month you're adding $50. Okay. Find the x-intercept. Does it make sense? And as long as they called it the x-intercept, let's just use this equation at the top.
Okay. So then, would it be...
X-intercept means what? Yeah, no, we're doing it right. Okay.
To find the x-intercept, so it would be... Would it be 300, comma 0?
No, start from the beginning. What does x-intercept mean about y?
What?
Start from the beginning. When they ask about the x-intercept, the only thing you know is it tells you what y is.
So the only thing we know about the x-intercept is that it's multiplied by 50?
No.
That it's zero?
If I have a graph and I have a straight line, what do you know about y at the x-intercept?
0.
Okay, I'm going to keep repeating it because it's that important. Okay, so remember that. When you're talking x-intercepts, y is 0. When you're talking y-intercepts, what is x?
What?
When you're talking y-intercept, what do you know?
That x is 0.
Okay, those two facts, don't forget them. Those are critical to all of math. Okay, when they're asking about x-intercepts, you know y is 0. So if I take my basic equation here and I let y be 0 and try to solve it, what do I get? Solve that for x. What is the x-intercept?
Would it just be 350? Oh no, it would be 300.
Solve that equation for x. How do you solve it for x? What do you do first?
Minus 30? I mean 300?
Okay, so that gives you 50x equals minus 300. Keep going, solve it for x.
So then divided by 50 on both sides.
Okay,
And then
so what is x?
-6.
Okay, that's correct. You did the math and you got -6. Now they ask you, that is the x-intercept incidentally, but does it make sense in the context of our problem? What is x?
No.
No, it doesn't. In other words, you never have 0 as the total amount you invested because you start off investing 300. So you start off with 300 when x is 0. So to say when is your account worth or when is the total amount that you've invested equal to 0, never. And x being negative means never, because remember, x is the number of months that you've been investing. Time can never be negative. Okay? So when you come up with a negative time, does it not make sense? All right. What's the total amount of money you have invested after 5 months?
So it would be 50 times 5 plus 300.
Correct.
So 550.
550, exactly. Okay. C, find and interpret the Y-intercept. What do you know about the Y-intercept?
X is 0.
Okay, go ahead and plug in x for 0 and solve for y.
So 300.
Okay, and interpret that. What does that mean?
At 0 months or like your starting point, you have $300.
Exactly. That means you started by depositing $300. Okay, again, they're going to ask the domain and range of this linear function. Now, a linear function means a straight line, okay? And we already know that the x-intercept is way out here at -6. We know the y-intercept is at 300. Well, the y-intercept has to cross with the x-intercept. However, we know x can never be negative. So this really is not part of our domain. Our domain goes from 0 months to what?
300.
No.
Oh, no, to infinity.
Exactly. We can leave that investment in there forever. In other words, this line goes all the way to the right. Okay. Which means, and I'll write it in x has to be greater than or equal to 0 and less than or equal to infinity. And if I were to write that in notation format, you go from left to right, so it's bracket 0 because it can be 0 to infinity, and infinities always have parentheses. You never have a greater than or equal to infinity because infinity isn't really a number. Infinity is a concept. It means growth without bound. That's what infinity means. Just keeps on growing without stopping. So it can't be, infinity is not a number, so you can never have a bracket next to infinity. Okay. Now, if you look at this picture over here, we've already got our domain. We know it has to be from 0 to infinity, but it can't be negative. So this is not in our domain over here. Okay. So the range is what that can be.
So then 300 comma infinity?
You got it. Exactly like that. In notation, or in interval notation, if you were writing it the other way, you would say y has to be greater than or equal to 300. That seems easier, but only when you have just one interval. The advantage of interval notation is you can combine various intervals. Let's say I could be from 1 to 3, and again from 5 to 7, and again from 9 to 12. Then I would combine intervals like that. Okay? And it's hard to do that with this kind of notation. All right. Let's scroll down further. Okay. We did the total amount of money after 5 months. Since the last question, F asks about the M function, not the Y function. What was the M function?
M equals 50x plus 300.
Actually 50t plus 300. And if I'm going to call it the M function, I'm really going to write it like this. Now, what's the difference?
Because t
This
equals
notation right there says that the M function is a function of t. I am only going to find the variable t on the other side of the equal sign. I'm not going to find x, I'm not going to find r. I'm going to find t. It is a function of t. And that is better than that because you can say, okay, what is M after 10 months? So this is more powerful notation. It allows you to evaluate the function at a given number of t. I don't have any way of writing that. If I'm writing that top line there, M equals 50t plus 300, similar to Y equal 50x plus 300, I can't then say, well, what is M when t is 10? Whereas if I'm using function notation, which is M of t, then I can substitute numbers inside the parentheses. So what is M of 10?
800.
Okay. Now find M of t equals 1,000. How do I do that?
So put 1000 for t, which is then
Not for t. No, notice what this says. M of t equals 1,000.
oh.
That's the left side of the equation. That's M of t. So they're saying that equals 1,000. Everything else is the same, but it tells me that's basically when does the amount of money that I put in equal $1,000?
So then what you do, minus 300 on both sides.
Use your calculator here.
Then 700 divided by 50.
Uh-huh.
Is 14.
So what does that mean?
So in 14 months, you'll have $1,000.
Well, you would have deposited $1,000. You'll have actually more than that because you're earning interest. Okay? And that's a whole nother math discipline as to how you figure interest. But what this is talking about is the total amount of money you've put in. And yeah, if you look at 14 months and you go back to our original equation, 14 times 50 is 700, plus 300 is 1,000. All right. We got like 10 minutes. What other area besides word problems would you like to look at? There's a lot of areas here. I don't know that we want to do transformations. That's a much bigger subject than 10 minutes. Or sequences, or graphing linear equalities. We don't want to tackle those with just 10 minutes to go. Let's just test you a little bit on your algebra skill. Okay?
Okay.
It's not what I thought it was going to be, but that's okay. This is in the same kind of thinking as what we've been doing, so this isn't bad. This is just, remember, this came before what we've been doing. So what's an equation? In other words, let's again think of all your equations as being in this format. There are other formats for a linear equation. Linear means straight line, but this is the one you're going to be dealing with for most of the next year. So write a linear model, this is linear, that represents the total cost. Well, which variable is going to be the total cost here?
Would it be $50?
Which variable in my y equal mx plus b represents total cost?
The B?
No. It's the y. It's the thing on the left. Total cost. I'm going to call it total cost. Okay? Now, what is the total cost going to be?
We don't know.
Well, we do know. It starts, you got to pay $50 even if you don't have any time at all, and then you pay $70 per hour. When you see the word per, that means slope. Notice that this $50 doesn't have a per next to it. So whatever has a per next to it, that's the m.
Then it would be 75m plus 50.
75x plus 50, where x is what?
The number of hours or time.
The number of hours. So actually, we'd probably be better off calling this t. And then instead of x, it's t. So t is the number of hours. Now let's just check that. If you have 0 hours, what do you pay?
$50.
That's the startup. In other words, to even get in, walking into this recording studio, they're going to charge you $50. If you have exactly 1 hour, how much would your cost be? What is t if you have 1 hour, if you use 1 hour?
125.
Okay, good. Okay, so that's the equation, right?
Right.
Okay, so B, is it less expensive to purchase 12 hours of recording time at the studio or a $750 software program that you can use to record on your own computer? Well, first of all, What would 12 hours at the studio cost you?
$950.
We're going to substitute 12 for T. What's 12 times 75? 900 plus 50. So you're right. Now, a nicer way to say that, let's back up just a second. I want to make sure you understand this notation, is if the equation said this, total cost as a function of time equals 75t plus 50, that's a better way than writing that, and it's still in the format of that, okay? It's just using function notation. And so when they say 12 hours, what that means is TC evaluated at 12. And that's what's equal to $950. Okay? So, what's cheaper? Buying, what's the answer to be?
It would be easier to do the software program.
Yeah. Now, I'm not going to scroll down because I know what the next question is. How many hours would it have to be so that they were equal? So that the cost of $750 is the same. How would I solve that? We've already solved that TC of 12 equals 950. So if I say, how many hours would it be before this cost reached 750? What do I have to do?
Plug it into your calculator?
Well, tell me what to write first, and then we'll plug it into our calculator. In other words, I can't plug this into my calculator. It can't solve that. It's got a TC of T and it's got a T. But if I plug in 750 for the cost, now I know that that's equal to this. And I can now solve that equation. So 700 equals 75t. Divide 700 by 75 for me.
700 divided by 75? 9.3 repeating.
So 9 1/3 hours. In other words, if you're going to use that studio for 9 1/3 hours, it's going to cost you $750. So it'd be the same cost as the software program. So the bottom line here is that if you're going to use it for less than 9 1/3 hours, you're better off using the studio. But if you're going to use it for more than 9 1/3 hours, you're far better off buying this software program. Because you're only paying $750 for it no matter how many hours you use. Even if you use it 100. But the break even, and that's what all of these look for, is the break even. You want to bet that if I scroll down, that's the next question. No, it isn't. Apologize, but that would have been a good part C. Okay, and in fact, had we been on the previous section, that would have been part C.
Yeah.
Ellie, I'm going to let you go. We're at noon. And good luck. I imagine we'll probably be having a session or two and before your final.
Okay. Thank you.
You're welcome.
Bye. When can you do it?
Is there a time that you could do one?
Sure. You want to schedule it now? I'm happy to. When do you want it for?
Could we maybe do it for Wednesday
What time?
4 to 4:30.
I've got a 4 to 5 scheduled already on Wednesday.
Okay.
You can see my schedule, right?
Yeah.
You get your choice of all those other times.
We'll do 5 to 6.
Want to do 5 to 6?
Well, I have my other finals, and my mom doesn't get that, so.
Okay.
Well, study for your other finals. And
Could we do Tuesday 4 to 4:30?
You see my schedule?
you won't be here. You have your
All
class.
3 days. Monday, Tuesday, and Wednesday. I'm booked from 4 to 5 already.
We'll do 5 to 6 on
Okay.
Tuesday.
I don't want to.
We'll do 5 to 5:30 on Wednesday.
Okay, could I do 5 to 5:30 on Wednesday?
Sure. See if it finds your name in here. It should. Huh. I don't know why it doesn't find you, but it'll put you in there. Okay, so 5 to 5:30 on Wednesday, is that all? This is the week of finals, and so I would anticipate my schedule is going to get filled up pretty quick. It usually does the week of finals. Is there any other time you want to reserve now?
No, I think that will be good because I have my final on Thursday.
Okay. Half hour is all more you need to review for
Yes.
your final?
Yes, thank you.
You're welcome. Bye-bye.